Good morning, everyone. Thank you for coming and taking the space in this talk when the other talks are full. My name is Paul Stack. I am here to talk about securing applications and infrastructure with HashiCorp Vault. Everyone know Vault? Who doesn't know Vault? Does not know Vault. Okay, perfect. So we'll talk about it as we go through. I work for a company called Pulumi. Pulumi is an infrastructure as code tool. If anyone wants a demo of it, let me know. It's orthogonal to this talk. I'm a DevOps guy, and I'm an automation junkie. So I just love building these automation solutions and tools for people to do this. So we have a problem space right now, okay? It doesn't matter if we're in operations or development. At some point, we are going to have to manage the issue of creating better and more secure applications. Now, the reason I say this is that we are not very good at this. Okay, we develop, and we try and think that security is someone else's problem usually, and we don't really do anything about it until the end. And I can see some people smiling a little bit. It's true. It's really true. Okay, we leave the hard stuff to other people and hope that they get it right. And we just continue building our shiny systems and our shiny applications. The trouble is that we end up in a very difficult situation. Now, these are the two that have stood out to me in the past year. Unsecured MongoDB databases expose the Kremlin's backdoor into Russian businesses. Okay, of course, everyone has stories about the Russian government and how it got ways into different things, but this is actually a story that was spotted that there were accounts on thousands of MongoDB databases, admin@kremlin.ru, okay? If you run a database like this, like MongoDB, please, if you take anything away from today's talk, ensure that it is not open to the world. There are lots and lots and lots and lots and lots of databases that are open and people can just go and steal whatever they want, especially NoSQL databases. And the second one is the Elasticsearch database. Leaked most of Ecuador's citizens' details, including 6.7 million children. Okay, we're in the era of cloud right now. Okay, and because we're in the era of cloud, we are being enabled to do more stupid things. Okay, what I mean by that is when we were in traditional data centers, we would have had very stringent networking controls that would stop people being able to come and read our databases at our network. Okay, when we're in the cloud and we're being told that we have to move to the cloud, and because we're in the cloud, we can move fast and we can use these hosted services, we're not ensuring these stringent restrictions anymore. Okay, and we will do something like we'll spin up an Elasticsearch cluster as a hosted service, and we'll allow people to hit it very easily without these security groups. There's a great website that you can go and you can find out if you have actually been included in any database breaches. Okay, it's called Have I Been Pwned? It's by Troy Hunt, and it has millions and millions and millions of records. And I just thought I'd run one of my emails. I have multiple emails. And I've been involved in already 4 breaches in the past few years. Now, this is an actual email address that I know I only use in a specific place, and not only has it been breached, but it's been shared already amongst different things. We need to get better at this. We really, really, really need to get better at security of our systems. And I'm not just talking about our application security, we need to get better at our infrastructure security as well. Any infrastructure people in the room? Okay, it happens, okay? It really happens that we have a big split of developers and infrastructure people. In that case, I would have put my hand up. And if I would have said, is there any application developers in the room, I also would have put my hand up. I try and do a bit of both, okay? Because I think it's important to understand both areas. Hands up if you run TLS in your production systems, but your development systems are non-TLS based. Okay, so we have two web services talking to each other, 2 applications talking to each other in a non-TLS manner on your local machine, but in production they talk to each other via TLS. Anyone have that scenario? Anyone have full TLS working locally? One person, you're my favorite person in the room. Okay. So what the problem is right here is that if you have this TLS-enabled system in production and you go to deploy your application for the first time, then you're usually in a scenario of, well, it works on my machine because everything works as expected. It works in the development environment. It works on all the different things. And we usually get TLS initialization problems or setup problems in production because we didn't expect that that's how it was going to happen. What happens if you have a microservices-based architecture that looks like this, and you have hundreds of web services talking to each other? Okay? How can you identify and pinpoint where a TLS problem is if you don't have these things running locally on your machine? Okay? We'll look at a way of generating TLS certificates in a second. Okay? Hands up if you have static database credentials in your application. Pretty much every application nowadays, people generate credentials. And what I mean by generating credentials is you'll have a set of credentials for dev, and a set of credentials for testing, and a set of credentials for production. And those will be, of course, they won't be embedded in the application itself, but the application will be aware that this is my credentials. They will get them from maybe environment variables or a configuration file that's encrypted, but your application is statically configured with those credentials. Okay? What happens when, and I do stress when, something happens and we're in a situation and we need to make a deployment to change the credentials? Okay? What happens if your database has been compromised? Okay? You have to reset your passwords. You have to go around all the applications in your company and reset all the credentials. It's crazy, right? We should be in a situation where we can do this easily and automatically. So this is where HashiCorp Vault comes in. So for those who do not know, HashiCorp Vault is a tool that will allow you to do many things with regards to secrets. Okay, and what I mean by that is it does secure secret storage, it has dynamic secrets, it does data encryption at rest, it does leasing and key renewal and rotation. It does revocation of leases. It does integrations with databases like MySQL, Postgres, all these different things. It even has custom plugins that allow you to do PKI management, SSH keys. It allows you to do dynamic secrets on AWS, GCP, all of these different things, okay? So Vault is like, some people have described it as the Swiss Army knife of secret management, okay? Now, I'm going to talk about today how I used Vault at a previous company in order to do a lot of what we've just talked about. I thought it was better to give a real-life use case on how we manage the secrets and the TLS certificates for the company so that we could understand and show different ways of doing it. It's important to note we had a specific setup for Vault. Okay? We had a 3-node Vault cluster. Okay? So it was highly available. Okay, so Vault runs in an active-passive scenario. You can have one Vault instance or one Vault node in your cluster, but if that one goes down, you're dead in the water. So it's always best to have more than one, and you usually have an odd number so that you can fail over very easily. Okay, so we had Vault was backed by Consul, which is another HashiCorp product, and it was storing our Vault data in Consul. And again, we had to have an odd number of Vault Vault nodes because of the way they have gossip protocol between them. And lastly, each Vault node had a console client running on it so that it could communicate with each other. Okay. And then we had an optional TLS proxy that sat across the front of everything that meant that we could talk to a URL like vault.mycompany.dev, okay, or vault.mycompany.prod, and so on and so forth. So it was. Otherwise, we would have had to make a request to the Vault cluster. If you didn't hit the correct machine in the Vault cluster, it gave you the in the response, it gave you the address to hit the active node. But this always returned the active node for us. Okay, so you just think of like HA proxy is a great way of putting that across the front. First thing we did is we set up our secret engine. Actually, you know what? I could just show you some code for this. Don't worry, I'm going to share. There we go. So we set up 2 secret engines, okay? We had, this is for PKI, okay? So this is for our TLS infrastructure, and then I'll show you how we did the database stuff in a second. Now, we created a root certificate for our company, and we created an intermediate certificate for our company. Okay, so by doing that, we had two specific stores that were kept independent of each other. Now, I gave this talk very recently, and somebody asked me why. Why can't you just use one store for that? So the answer I gave is that it doesn't matter what happens to the intermediate certificate because it is generated on a root certificate. So I wanted to keep the root certificate secure away from everything else, that only specific people had access to read the root certificate or to change the root certificate, okay? So it was kept in a completely separate store, and we could generate other intermediates based off of that root certificate, okay? After we generated the root certificates, we generated our backend cert. Oh, excuse me, I apologize. We generated our intermediate certificate request, so our CSR, and we actually got the real certificate back for everyone. And this is the intermediate certificate right here. So what this meant is that inside Vault, it was programmed that when anyone made a request to get a certificate, there was an automatic CSR in place that would assign the certificate based on the intermediate that it was requested against. Okay, so the applications, and I'll show you how the applications and the infrastructure were doing this, they were making requests directly to Vault, directly to the server and saying, give me a certificate. The certificate had a very short lease, a TTL, so that we kept everything running in sync as much as possible. And I have all the code, and I'll show you a demo of this in a second, okay? So, and then every single application or piece of infrastructure had a specific role. Okay, so we had the top level, which is the root certificate, then we had the intermediate certificate, then we had applications that were, each application had its own specific role that it could create its own certificate for that application or that piece of infrastructure based on the intermediate, okay? This is an example showing how we did with CockroachDB. So it's a database cluster that we were using, and we could actually see that we were generating a 1-week certificate for our CockroachDB cluster. And we could actually see, we could generate leases, and we could see that we could allow localhost access to it, so when operators needed to go on and actually like run some commands. Everything we did was managed with Nomad. Okay, so HashiCorp Nomad. Okay, so it's a scheduler tool. If you think of Kubernetes without the hype, then that's Nomad. It's a very simplistic, a very easy to run scheduler so that we could actually scale up and down very easily, and it had very, very, very good integration with Vault. But because of that, we were able to run, oh my God, the screen is looking terrible here. If I just show you some code, it's easier. If I go into the infrastructure, then I can show you some of the jobs, the test jobs that I've been creating today. Provider. There we go, it's better. You can actually see it a little easier now. So we downloaded the Cockroach DB binary, and we had a direct integration from our Nomad template to Vault, which basically says this Nomad job has access to interact with Vault using the Nomad PKI policy, which I can show you in a sec. And what we would say is that this is the main part of what we were trying to do right here. So this basically says, this application, when it starts up, I want you to issue a certificate for CRDB, so CockroachDB, based on the role that we had generated before, using these IPs, using this database cluster name, and we would actually take that, and it will actually grab a PEM, so a certificate type, and it would bring it out. When it was actually brought out, it would save it to a bundle.json file, and it would actually be used as part of the certificates. So we had a cert there, And we know that the search there is where it actually brought it out. And the Nomad cluster, or excuse me, the cockroach database job would start up and it would immediately read that specific certificate and it would start up. So what happened is, when this changed, so every time Nomad went back to Vault and said, hey, give me the certificate, and it would generate the same certificate, so it would no changes back. But when it did actually change, what it would do is it would send a SIG hop to our database node, and our database node would restart automatically. Now, we had splay in here, which is something inside Nomad, which says, don't restart all the database nodes at the same time, because if you do that, you're in some trouble. Okay? You needed to restart like a piece of the database apart from each other, otherwise your application would go dead. So we had all of these jobs that were continually doing these different things. Now, I mean, we had Vault in there, we had, we had Cockroach DB in there, we had Nomad in there, we had other custom applications that we wrote, infrastructure applications that we wrote, and it was very easy for us to actually do it. So we had 18 application operations working in the same way. Okay, all built in exactly the same manner. Each application had its own role. Each application was able to generate its own certificates, and each application certificate was based on a TTL that was specific to that application. Okay, if anyone wants to see some code around this, come up to me at the end. It's easier. Okay, so we now have a TLS-enabled database. What do we do with the database? How can our application allow us to do that going forward? So again, Jesus, it's so terrible. There's a light. So each application was built in the same manner. What? There we go. CD. If I just look at something like SSH PM serve. So this is a specific application that was running. It was a Go application, a small binary that was generated. And each application was able to talk and issue a certificate for the database itself. Because, of course, it needs to be able to talk to the database, so it needs to go off to the database and says, hey, give me the client certificate that's required. And it had the common name of root. This was just on my dev machine, you'll see later. And because of the intermediate path that we were passing in, it was one of the things that was there. It was in a situation that it could actually generate the certificate and send the client certificate back. Now, the TTLs and the client certificates were 720 hours. Okay, so what we could control those, we could actually make those as low as minutes, because depending on the type of the application that was there. So every application was able to request the same client certificate as the database that was actually issuing the certificate earlier. So it was actually set up very, very easily and very simply in how we did it. And the application startup code was what needed to change here. The application startup code is where the meat of this system actually happened. Because what we would have is we would generate, it would basically go off and say, give me the configuration. That just looks so terrible. I'm so sorry about this. It looked perfect with the lights off. I'm sorry. So the application would start up and it would basically say, I need the database configuration. And the database configuration would just read a lot of environment variables that were set inside Nomad. So the Nomad, each variable was like, give me the connection, or the host, give me the port, give me the username, give me the password, give me the client certificate, the key certificate, and so on and so forth. And everything was very cookie cutter. What I mean by cookie cutter is that every application was built in exactly the same way. Okay? We had many, many, many applications that were built in this way. I think there was 139 different applications built in exactly the same manner. And a developer was able to cut a new application and roll it out very easily and very simply. So I'm going to show you how we did this. So I'm going to give a demo on this. So I have a Vault node running right now. I do not have a Vault node running right now. So I'm just going to run a Docker container for Vault, and we can see that at the bottom it's finished upgrading its keys and it's successfully unmounted Vault. Now I have some code that I wrote, as I showed earlier, where we generate root certificates, okay, intermediate certificates, and the PKI roles, and the secrets for each of the servers. Now if I run Terraform plan here, this Terraform plan will talk to this container, and you'll see that it's actually going to churn out some information. So the first thing it's going to do is it's going to mount the PKI certificate backend. Okay, you'll see that it mounts two certificate backends, one for the root and one for the intermediate. And then you'll see that it starts generating some leases. So if I say plan, we can see it's 53 things to add. So this is a tool called Terraform. Anyone know this tool? Okay, so Terraform is an infrastructure as code tool that allows you to do things repeatable rather than having to go to either the Vault UI or using the Vault CLI directly. We're doing it in a programmatic manner so that we can actually push the same code across different applications. So we say Terraform apply, and we can see that it's actually gone off and did everything. Okay, so it's 53 resources that have been added, and we go back to our Vault cluster. And we can see that it's mounted some namespaces here. Okay, we can see that it mounted the root certificate and it mounted the intermediate certificate. And we actually, at this point, we have a real certificate store that we can start generating certificates from. And if I have a look at the state file, then we can see, if I really want, here's the intermediate certificate with the key and with the chain and everything that's there. So at that point, we have a real certificate that we have generated by hand. Now, if I go just to show you, and I destroy this again, if I can spell right, I've just killed my Docker container. Amazing. Amazing. Docker RM. Terraform destroy, yes. It's fine. It's because I've deleted everything, so there's nothing in there anymore. So rm terraform.tf state. Okay, cool. So if I apply this again, we can see in my state file a certificate. And what I want to do is show you that if I destroy it and bring up a new one, then it'll be a different certificate. Okay, Terraform apply again. You'll see that there's actually 0 in my state file right now, so there's nothing in Vault. We can even go back to Vault, and we can see that it's successfully unmounted the namespaces that were there, and it's revoked the leases of these certificates. Okay, that's the most important thing. These certificates are now no longer useful in the world because they've been revoked, and if anyone tries to use them, they'll get the root doesn't exist. So if we go back and apply again, we can see it's successfully mounted new PKI backends. And if I go in and just grab the root certificate, the chain, it ends in SY. And we can see the certificates are actually different. Okay, so every time, for dev purposes, I was able to spin up an entire cluster, create all my certificates, my applications, even in development mode, would talk to this Vault cluster using Nomad locally. It would issue its own certificates. When I was happy and I was ready, I would just destroy everything and bring it and take it away. And it was built in exactly the same way for local development as it was in production. Okay. So how do we manage the difference of secrets for databases? Okay. Now, this database doesn't exist right now, but there is a backend specifically for Vault as a Postgres database. Okay. Now, what the Postgres database does is you tell Vault the root credentials of your database. Okay. Vault is secure enough that it can manage the root credentials for you. Then, because of that, it will manage the leases of what applications can talk to your database. Okay. And it will actually grant them temporary access credentials based on the rules that you allow it. So in this case, I'm basically saying, let's start the Vault mount for database. I'm just going to remove this a second. And if I Terraform apply, excuse me, you'll see it's added one new resource. And we can see that it successfully mounted the database namespace. But then it said two different things. It started the secrets backend, which will be a periodic ticker. So what that does is it will periodically go to your database, and it will refresh itself with a new password. Okay? There's no such thing as a master root password that has to be stored everywhere. Vault has access now to manage your database, and it can grant the credentials that it requires. And based on that, we can actually create a resource which says the database that I want you to manage in this case will be this Postgres database, and it will have this username and password as an initial username and password so that it can connect to the database. This one doesn't exist. So what will happen here is that Vault will, the error will come back and says, I can't connect to that server because SSL isn't enabled on that server, so Vault can't go and manage that specific one. So if there was a specific integration that you had, or you had RDS, or you had like a database server or a cluster locally, Vault would be able to go off, manage that connection, and then applications would be changed to programmatically talk directly to Vault. Now, it would look a little like no, where's my picture gone? Where's my picture gone? I've lost my picture. So the applications would no longer talk directly to the database. They would talk to Vault first. They would say, Vault, give me a temporary credential that I can talk to your database, and they would go off and be able to make any request as expected. Okay. Exactly the same things happen with your AWS accounts or your GCP accounts. You can give Vault the root access to your AWS account, and it will generate it will generate shorter-lived users that can be used for your infrastructure management. Okay. Vault is secure in this manner. Anyone have any questions? People are looking confused. Nobody? You just want me to shut up? So it's really a case of, by allowing to use this tool, we were in a situation, excuse me, that Vault was controlling the security of our entire system. And by having local setups of everything we did, just using Docker containers, like this is exactly how I worked before. I had a Docker container of a Vault node and a console node that was backing it. We were in a situation that we could run exactly the same things locally as we did in production, which means that when it came to deployments, everything was just easy. It just happened. A deployment in production for us was exactly the same as a deployment in development or in testing and staging and so on and so forth. If you manage to get it in this way and this specific role, then TLS problems disappear in production. Excuse me, that's an overstatement. What I mean is TLS setup problems will disappear when you move things to production. When you have to revoke leases or revoke database credentials, it will do that as well. So all you have to do is go to Vault, and you would say, revoke these credentials or change this, and there's a command that would actually allow you to force a new DB rotation, and no existing passwords would use. So when something happens, and I stress when, because it's only a matter of time if you haven't had a problem already, you could very easily revoke and change the credentials. Make sense? Awesome. Anyone any questions? We have time. No one. Is anyone using Vault in a similar manner? A little. Interesting. Tell me what you do with it. Okay, so you're just using Vault, and somebody else put their hand up? Someone? Oh, okay, so you use it to store credentials just as a key value store, is like just pushing secrets in? Got it. And then do applications talk to Vault to get those credentials? Do applications that need to talk to Kafka, do they talk to Vault to get the credentials for Kafka? Okay. So you do it in one of the secret backends, okay, in exactly the same manner. It's just you're using the Kafka backend rather than the Postgres backend. Yeah. So the PKI integration for us was the biggest part because PKI is something that people are predominantly bad at, and being able to use Vault as a certificate authority meant that it became much easier even for developers who didn't know anything about PKI or about TLS certificate management. They could do it in a very simplistic manner. Because we had the code that did it, so when I show you the code that does it, so we mounted our PKIs, backends, we generated the certs, and you can see it's a type exported cert. It even has like key type and bits, okay? We have specific TTLs on it, and then we could actually develop specific rules. Now, of course, we can refactor this very easy to say, you know, have one module in Terraform that you just push data into and you wouldn't have to copy and paste it. But for the purposes of this demo, I just wanted to show that everything could be just exactly the same. So this is using the back end of our intermediate certificate, and we generate a rule for Vault, and we know exactly the max TTL allowed for the certificate, and nothing can actually exceed that max TTL. And you can see every application had the same. NATs, our process managers, all of them. Everything was built in exactly the same manner. Then we had the secrets themselves, okay? So this is a specific cert that was generated for Vault, and the reason that we had to do this, excuse me, is we had to write another application. So let me step back. Somebody asked me in a previous talk on this. They said, okay, so you have your applications talking to Vault, and you have Nomad talking to Vault, and being able to generate its certificates. What's renewing the certificates in the TLS around console and Vault? Because you have everything from the bottom talking up into your system is automated, and it's renewing its certificates, and it's doing everything that it needed to. But are you telling me that you had long-lived certificates for everything else at the top level? You know, you generated Vault once, and the certificates were there, and nothing ever changed? And the answer was no. We wrote a sidecar application, which actually generated certificates using Terraform, and it would go off and rotate the certificates in console and Vault themselves. Okay, because we had long-lived certificates nowhere else in the stack. Why would we want it in our actual real certificate store that things would be, you know, a lot more brittle? Because if it disappeared, or certificates were leaked, or secrets were leaked around our Vault stuff, in that point we were in big problems. So we actually wrote a sidecar which would do it. And these two specific things would go and grab the certificates. So we would grab certificate for Vault, we'd grab certificates for Nomad servers, and the Nomad clients, and the CLIs and the console CLIs that would go there. And this application would take those certificates, go off, place them on the machine, and run SIG-Hub for each of the processes to restart the servers when we needed to do it. And then we had specific policies. Okay, so we had an administrator policy. We had each application itself had its own policy that needed to be doing it because it needed just to be able to talk to specific pieces. So for example, file beats, which was for our log shipping, needed to be able to request a certificate, so it only needed to do read and list. Whereas administrator needed to be able to do create, read, update, delete, list, and so on and so forth. So specific policies were in place that allowed only specific targets of each individual operation. So if you needed to go and generate a new certificate, your application needed to have the correct policy. That was embedded into Nomad, so Nomad would be able to do that for you. And lastly, we could allow tokens. Okay, so Nomad was actually talking to Vault, and Vault was issuing a token to Nomad so that it could talk to it. That token had an expiration. Okay, and because it had an expiration, if it expired and Nomad wasn't able to get a new certificate, all of our deployments, all of our applications would have failed. So we actually told Nomad that it has its own specific token authentication, and it could generate a token based on what we were doing. So everything was completely changed around. Everything was talking back to Vault as the center of our world, and Vault was able to generate everything that it needed to do. Are we sure there's no question? Question? Great question. So the question is that we're talking about databases, and sometimes we need manual intervention to go into a database to be able to look at user actual data within our database itself. So what we would have had to do there is we would have had to go to Vault, and we would actually have had to request from Vault using either the Terraform configuration, or in this case, because it was temporary credentials, we just run a simple Vault command, which says, give me read-only access to this database, and the lease of that credentials would be like 10 minutes or whatever, and it would just give you those two, the credentials, and you could log into the database that way. Oh, good question. So as an extension to that, does that mean that you always need an administrator available to generate the certificates? No is the answer, because how Vault is set up, anyone who could access Vault and ask for it based on the role they have within the organization, it doesn't matter if they're an administrator or not. In this case, it was a developer saying to Vault, give me temporary credentials so that I can go and read it. In the same way as the application can go to Vault and say, give me temporary credentials that I can connect to the database. So it's like it's a login to Vault, but it's an authenticated role that you have as a user that would allow you to request credentials that way. Make sense? Okay, so that's how we do it. And then that way, of course, these passwords were not long-lived, therefore they couldn't be shared around, and they were for the specific of that role, the lifetime of exactly what you wanted to do. Yeah, it is an additional layer, but it's a layer of security, okay? Because what we would have done what we would normally traditionally have done, we would have these credentials, they would be shared around, okay? And then there's pointless having credentials if everyone knows what they are, okay? So in this case, a credential was genuinely created specifically for the role of a user going to read the database. That had a specific lifetime. And of course, because of the fact that it went through Vault, Vault audited it and says, this user requested credentials to read the database. So you had the full audit access at that point as well. It logs it. Vault logs everything. The audit trail of Vault will, anytime someone made a request to Vault, it was audited by what user and what they wanted. So at that point, we had a full history. Now, of course, that's very good in this case of talking to a database, because if something went wrong with the database, immediately you would know, well, person X went to our database, they requested credentials, 5 minutes later, data has either been updated or missing, or something's happened, or someone's ran a select statement that locked the entire database. We know where that's come from. We can go and talk to that specific person. So having that central layer, and yes, it is an additional layer of overhead here, meant that it's very controlled and very easy to understand what's going on at any time. And of course, if the person was doing something wrong in the database or causing problems, the Vault administrator could just go and just run a revoke, and immediately the credentials would disappear and they couldn't do anything else. Question? So it's a great question. In a specific scenario, if you had an application that needed to create credentials to the database, and it's a long, long, long-lived access to the database because it's doing a lot of work, what would happen if it was outside the TTL of the request? Is that what you're asking? So in that case, for that specific example, you would have a role specifically for that application, and the TTL for that role would be much higher. The lease time would be much, much higher for the secret, for the credentials, and then at the point of which the application starts and stops and restarts, it would request a new one based on that. So everything is segmented into specific roles. It means you can control individual roles independently from each other, and everything can be audited based on that. And I'm not saying audit in a bad way. You would be able to see when it created new credentials or when it made a new request that it was starting up in order to get the new credentials. Yes. I can talk to you directly about that specific use case after. It's easy. I know what you're saying, and I just want to be more succinct when I'm trying to show you on that one. Okay. Any other questions? Question? Oh, got it. So the question is, does Postgres start up and talk to Vault? The answer is no. So it's the other way around. So Vault will talk to your Postgres server. Okay, so it can be an existing server, it can be a new server, it doesn't matter, but you're basically telling Vault, hey, go and manage the credentials for this existing database right here, and based on the role that you give it, in fact, there's a really good tutorial on the HashiCorp Learn website for this, and effectively what it does is that, okay, so what it does is uses an existing Postgres server, and then based on the existing Postgres server, we will go and enable the secrets backend, and on that we will configure the Postgres secrets. So as you can see, that Vault is what talks to Postgres itself in order to manage those credentials, and then you can actually go and test that it generates the new credentials every time. And notice that you're making a request as like a specific username and password. But it actually says, at that point, when somebody has issued credentials, go and force the root password of Postgres to be updated, and then they'll try and connect to the same database and it'll fail. So Vault is more aware of everything else rather than things being aware of Vault. But your application would need to be aware of Vault in that scenario in order to actually pull the credentials so that it can talk to Postgres. So it's like a two-step. Yes. Yes, exactly that. And a temporary password for that user as well. Notice in this specific use case, you would pass in the username and password and the connection URL that's there and any roles that's allowed. So you can have like a read-only specific role and it'll generate credentials based on that for what the lady said at the other side. So based on that. Any other questions? Question? Yes. Yeah. So the question is, if Vault is down, is everything down? Yes, 100%. This is why I said right at the start that you need a cluster of Vault nodes. Okay. For development purposes, it's fine to use like a Docker container and have a one-node cluster. In production, that does not work. Really does not work. Okay. You need an active cluster, and then you also need some passive nodes because the data replication happens between the Vault nodes. And if one goes out of the loop, the others will come in. One will elect itself as the new active node, and you will still talk to that. That's why I had the proxy across the front Okay, I used HA proxy or a small application called Goton, and we always just hit a URL, and under the URL, based on how we deployed it, something was always available to give us the node. Now, if 3 nodes in Vault went down, it's probably because of a bigger problem in our entire environment, and at that point, we're pretty much on fire anyway, right? Because we deployed it in AWS, each node was in a different availability zone, and if all 3 went down, that was a bigger problem. It meant that there was a whole region inside AWS that was having problems. So we could quickly roll across to the other one. So yes, 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 yes. You need a good Vault architecture in order to do that, and you could go to the HashiCorp website, and it will talk through the correct ways of deploying the architecture. Any other questions? I have 5 minutes. So the question is that how does certificate revocations work? Does Vault notify or not? Well, the certificate is based on a TTL. It's based on it has an expiration date. Okay, so as soon as it hits the expiration date, the certificate's invalid anyway, and requests would fail. Oh yes, you can. I apologize. Yes. In a PKI certificate, you can issue a request to Vault that says this one is no longer valid. Don't issue new versions of this certificate. But if a certificate is already in use by an application, it's there in the wild, right? But that's why you keep the expiry dates very short, because if you do need to revoke it, the application will need to request a new one in its place. So it's always about trying to keep that TTL as low as you possibly can in order to do it. Then you'll always get fresh certificates, and you'll not be in a situation where you have old, revoked certificates around. So we tried to keep our certificate management to less than a day, okay, for our applications, because of the nature of what we were building. We were positive that every application will be deployed or at least restarted once a day, and it would always get the freshest, cleanest certificates. Yeah, as I said, this is a demo that I'm showing right now. So as little as possible. Even our databases were less than a day in production. The certificates for databases. Question over this side. So the question is there anything that Vault can do to notify? Like email or Slack or something like that? The answer is I don't know, to be totally honest with you. I'm pretty positive yes. The reason being is it has the full audit, so it'll actually be able to send notifications. I've never used that specific feature, but I'm pretty positive. We can look at after actually, and I can show you. So. Yeah. I'm pretty positive the answer is yes. I've just never used that specific feature. Any other questions? I have lots more. I'll go here, and then I'll come here, and then there, okay? This one. Oh. Is it... So the question is it's a question around the best practices of running your Vault infrastructure. I specifically ran them on VMs. Okay, the reason I specifically ran them on VMs is that we were able to control startups. We were able to control, these were pre-baked images on Amazon that were baked with Vault into the system and stuff like that. My personal opinion is I'm not a huge fan of containers. Okay, because people can get themselves into a lot of trouble with containers. I'm a traditional infrastructure guy. I've been doing this a long time with traditional VMs, and I like that way of working because I have sidecar applications and sidecar processes that sit on VMs that I can monitor different things. The answer would be you could indeed run it as a cluster of containers, but it's not designed in that manner because by the nature of containers, they're designed for a little bit more volatility, right? They're not really designed as real stateful systems. This is a stateful system. Okay, so I would suggest that you run it on more traditional infrastructure. This person. Excuse me, I'm sorry. Lessons learned on this. Yeah, the biggest lesson is why I did not do this at other companies. Okay, the reason being is that we were able to control things in a much better manner here. So just for full disclosure, the company I worked at before where I work now was Samsung Research, and that's where we were using this. So it's a pretty large company that we wanted to keep, secret management in a high regard because it was, a public-facing company that people would actually have a field day if you were doing things in a bad manner. At a previous company I worked at before, secret management was a disaster, like an absolute and utter disaster. And we were hard coding connection strings, okay? Secrets were being leaked into our GitHub account actively. Like, you go to GitHub today and you do a search for AWS Access Key ID, and you will see hundreds of entries in there. So secret management is traditionally difficult as a developer. Okay, and then add on top of that TLS certificate management, it just became a nightmare. So this actually made life a lot easier, and I've been showing developers actively that TLS management is not as hard as it used to be because of tools like this. Personally, there has not been a negative aspect for me. Okay, and I am actively talking with other companies and trying to suggest maybe you move in this direction because it's a good thing to do. Even the director of engineering who worked with me at my previous company has gone on to another company, and the first thing he did in that new company was to put this system in place. So it was very successful for what we were trying to do, and with a little work to start with to get this up and running, everything just worked as expected. And I'm pretty much out of time, but I have one more question just here. Excuse me, can you say again? I'm really sorry. Oh, have I ever been in a situation where I've seen Vault deployed to Kubernetes? That's a question for a beer. Okay, I guess I have other thoughts on that. But the answer is no. I've never specifically seen it, but I know some people do it. And there are guides on the HashiCorp website that explain how to run it inside Kubernetes. Okay, so it is available and people do it. And I've just never specifically done it. So there's three key takeaways here. Okay, and I think this relates back to what you were asking about the positivity here. Developers were able to run the exact same infrastructure locally as they were in production. Of course, it was a subset. They didn't have the users and stuff like that. But it was set up in the same way that we had Nomad running the applications. We were able to deploy a new application to Nomad very simply, just using a command line. Nomad would talk to Vault. Vault would manage the credentials for the database, and the applications would talk to Vault in order to get the database credentials as well. Developers were able to run a full TLS setup in their production or in their local machines, and that was a big, big, big thing because deployments to production were a complete non-event at that point. It was just push the code, you know it's all tested, push it into the repository, we know all the credentials are all set as expected. The automated test would run and it would automatically deploy to production. I don't have any more time for questions, but come up at the end and speak if you have any other questions. But thank you so much and enjoy the rest of the day.